Hey guys, and welcome to the video on function notations. Many graphs we've reviewed in previous years are actually examples of functions. The aim of this video is to provide you a more detailed idea of functions and its notations. Let's have a look at an example that would lead us to a function. A plumber charges a $150 call-out fee and then $100 per hour that he is doing work. Let X be the number of hours that he works, and we'll let Y be the total cost in dollars. What we can establish here is Y is equal to 150 plus 100x. This is an example of a function. Informally, we say that Y is a function of x because the value of Y is determined by x. The variable x is the independent variable of the function, and the variable Y is the dependent variable because it depends on the x. A table of values is a really useful tool. Here is a table of values showing you the total cost in dollars, Y, for the amount of time, X, in hours that the plumber was doing his work. A function and its rule can be regarded as a number machine with inputs and outputs. For example, the numbers on the right-hand side of the column are the outputs of the function X. When the numbers are 0, 1, 2, 3, and 4, they're your inputs. Diagram above, we gave the name f to our function. We can now write the results of the input-output routines as follows, and we say it out loud as f of 0 equals 150, f of 1 equals 250, f of 2 equals 350, and so on and so forth, which leads us to our function, which is f of x is equal to 150 plus 100x. We're going to be using this notation throughout the course. So, what does this all mean? A function is just simply a rule in that we input x and the rule produces an output y. The function rule is almost always an equation with possible restrictions, and we'll look into that a little bit further in the next videos. And when a variable y is completely determined by some other variable x, we say that y is a function of x. Let's have a look at a few examples now. A function is defined by f of x is equal to 6x plus 2. Let's find f of 2. If we input x equals 2, we're going to get 14. And how did we get that? It was just simply putting in f of 2 is equal to 6 times 2. For every x, I'm going to be replacing it with a 2 plus 2, and I get 14. Okay, so in this example, I have f of x is equal to 2x plus 5, and I want to find out what f of 5 and what f of minus 5 are. Okay, so how I like to start any of these questions is actually writing the function out itself. Underneath, I'm just simply going to substitute, and for f of 5, I have 15 as my answer. As you can see, for every x, I replaced it with a 5. And I'm going to do the exact same thing for f of minus 5. Now for f of x is equal to x squared minus 4, I want to find f of minus 3. Once again, I like to start with writing out my function. And now for f of minus 3 is equal to minus 3 squared minus 4. Minus 3 all squared gives me positive 9 minus 4, which is 5. In my next example, I want to show that f of 2 is equal to f of a half. So what I'm going to do is I'm going to do each one separately, and obviously with my two outputs, I'll determine if they are the same. And there you have it. As you can tell here, both my outputs gave me the same answer, so therefore f of 2 is equal to f of a half. Alright, don't let this one throw you off. It's really simple. G of t is equal to at squared minus bt, so I don't have to do anything for this one here. It's already a given. Now for g of minus t, Now I'm going to have to add the two together. So for g of t plus g of minus t, I've got at squared minus bt plus at squared plus bt. You do not have to put in this bracket to separate it. I'm just doing that here to show you. So at squared plus at squared is 2at squared, and minus bt plus bt, that cancels. Your answer is 2at squared. Okay, again, this one is really simple. It looks a little bit daunting just looking at it, but it's actually really simple. What I've got here is I've got f of x is equal to minus 2x for x is less than negative 1. That means whatever input I have that's less than negative 1, I'm going to be using f of x is equal to minus 2x. And f of x is equal to x plus 3 if x is between minus 1 and 3. And f of x is equal to 6 for every x value. Alright, let's get to it. So for f of minus 2, I'm going to have a look here. That exists when x is less than negative 1. For f of 0, that exists between minus 1 and 3. So I'm going to give it the blue color. And over here for f of 5, that exists when x is greater than 3. So let's put all that information in. So for f of minus 2, I'm going to be substituting into f of x is equal to minus 2x. And my answer is 4. For f of 0, I'm going to be subbing it into f of x is equal to x plus 3. Okay, for f of 5, I'm going to sub it into f of x is equal to 6. I have no idea why I chose a highlighter color, but let's just work with it. So all up, my answer is going to be 4 plus 3 plus 6. Let's see. And there you have it. Next video, we will look closely at the most important and helpful way to represent a function, and that is a graph. Thanks for watching. Please don't forget to subscribe for updates on our latest videos. More helpful tutorials are yet to come.